Welcome to CBT Nuggets Linux in the Real World series video number 2, where we're going to talk about networking. And before I get down to the networking itself, I just want to say, wow, did you all come through when it comes to feedback? I was hoping that I would come and find all the answers and all the responses to the survey. I would come up to my fancy little mailbox here. Obviously, I'm not an artist, and it would just be chock full of all sorts of awesome feedback from everybody that filled out the surveys. But in fact, here in the background was my house. I apparently live in an ugly house. And my house was busting at the seams with all of the feedback I got, and I thought, my goodness, how am I ever going to get through all that feedback? But little did I know that back in the background, way back in the skyline, there was a mountain, and that mountain was so full of feedback that the top of the mountain came off, and survey responses were spewing out like a giant volcano. So maybe that explains a little bit of the amount of feedback that I got, and maybe you're just a little bit worried about my sanity. But wow, we got so much feedback. I'm so excited. We have so much stuff to go through, and I think networking is an excellent place to start, because when you're setting up a new network or you're setting up a new bunch of servers, networking is how they talk to each other, so it's key. So let's get down to business and talk about some ways that you want to set networking up on your system. Let's get rid of my mailbox, house, and volcano, and we can get down to business. So first in this nugget, we're going to go over IP addressing in general. We're going to talk about public IPs versus private IPs. When we talk about private IPs, the ranges that are considered private. And then when we talk about the systems, we're going to talk about static IPs using DHCP for dynamic addressing, or a combination of both in your network. Then I want to go and actually show how to configure systems for networking, both Ubuntu and CentOS based systems, how to set those addresses, how to manage the different types of addressing, and then I actually want to finish up with a really cool section on Ethernet bonding. It's neat stuff, and most servers now come with at least 2 Ethernet ports, and a lot of times you don't take advantage of those unless you specifically assign them separate addresses or do this really cool bonding thing. So let's first talk about what your network is going to look like and what sort of addressing maybe you should have. Well, first off, I realize this is going to be a review for a lot of people. This is going to be stuff that you've already learned if you've looked at Cisco stuff at all, or if you've taken Linux training, but I just want to touch on it just so that we understand and we're all on the same page. First of all, when we talk about public IPs, we're talking about actual internet addresses that are routable on the greater internet. So if you were to do a DNS lookup for www.cbtnuggets.com, you would get back a public IP address. So a public IP address is one that's routable. And these are the sorts of things that you generally see assigned to routers and firewalls. Sometimes servers, but I'm going to say that that's a little bit scary to assign a public IP directly to your server. It's really good practice to assign your public IPs on a router or a firewall, and then have ports forwarded in so that you're just poking holes in what would be a much more secure setup like a firewall or a router. But that's for a little bit later. Basically, public IPs cost money because these are what you get from your ISP. This is where your bandwidth comes from, right? Your public IP is the one that is facing the internet and the rest of the internet can see. So a public IP costs money, and that money is more if it's a static IP, meaning if it's always the same numbered address that you have assigned to your router, firewall, or Ethernet port. Or sometimes, actually almost always, for home usage, you get a dynamic IP. It's still public, okay, it's still routable on the internet, but it changes. So one day it'll be 12.6.5.8, and I have no idea what that is, so don't go like attacking that IP address. But one day it'll be one address, the next day it'll be another address. And for home use, that doesn't usually matter, because if you're just a home user accessing the internet, it doesn't matter at all what your IP address is, because you're just reaching other people on the internet. You're not running services. Now, if you do want to run a couple services, you can be sneaky and use dynamic DNS. And this is something, remember I said your public IP changes when on your home address, well, you can also change a dynamic DNS setting so that no matter what your address is, say home.seansreallycoolplace.com, will always resolve to my public IP at home as long as I update my DNS whenever my IP address changes. But that's another whole story. Basically, when we're talking about public IPs, it's anything that is a live IP on the internet that other computers and other people can access directly. For home use, it's often a dynamically assigned and changing IP address. For servers, it's generally a static or the same IP address all the time, never changes. That's usually how it goes. And static IPs particularly cost more money than a dynamic IP. But that's what public IP is. And then lastly in the mix, we have private networks. Now, I'm sure that you're familiar with this at least somewhat. And what I want to talk about now is when you're setting up your network, whether it's a test network for doing these nugget things that we're learning together, or whether it's a business you started working for, whether it's a company that's asked you to set up their network, set up their servers and their internal clients, you need to know what private networks are, because in an internal corporate environment, all the internal computers are going to have private IP addresses. That hasn't always been the case. Actually, when I started back more years than I care to admit ago, all of my internal computers in my network had live public IPs. We had two Class C networks. We had 512 live public IPs, and every computer in my network was live on the internet. That's a scary, scary thought now. You don't want to have your computers live on the network. You're opening yourself up to get hacked very, very quickly. So now almost every single internal corporate network has a private IP range internally. And these are, I'm not going to talk about what classes are and all that stuff. That's more a Cisco class. But basically, there are three subsets of private networks. What these are IP addresses that are not routable on the internet. You can route them inside your network. You can do whatever you want with them on your own hardware, but you're not going to reach across the internet to one of these addresses because they're not routable on the greater internet. So, Class C addresses, there are 256 Class C networks that you can use for your internal private networks. What those addresses are, they start with 192.168 and then dot any number between 0 and 255, dot any number between 0 and 255. Basically, a Class C network is a network where this last octet changes. There's also a subset of Class B addresses that you can use. Now, a Class B address is an address where the last two octets change. So here you have 172 dot either 16 or 17 or 18 or 19 all the way to 31 dot anything from 0 to 255 dot anything from 0 to 255. Now, there are only 16 available private Class B networks. The 172.16 is one of them. 172.17 is one of them. So anywhere 16 to 31. This is the range of private networks that are not routable that are Class Bs. Again, Class B means that these two octets enumerate. And then a Class A, there's only one single Class A network available. But a Class A network is enormous when it comes to number of IP addresses. A Class A starts with 10 dot, and then all three of these octets enumerate from 0 to 255. So what that means is you can use any number inside this range inside your internal network, and they'll all be able to see each other, and one Class A is plenty. Because here we have every Class C has how many addresses? It has 256 addresses, 254 usable addresses if you want to get technical and you're a Cisco person. And there's 256 sets of those. So all together, if you add all the private Class C networks together, you end up with about 16,000 addresses that you can use. Now the Class B private networks, you'll see you have these 16 sets of Class B addresses. So if you add all of the available Class B private networks together, you end up with just over 1 million usable addresses, because there's a lot more things that change here. But then Class A takes the cake. because it has over 16 million addresses that can be enumerated in right here. Now, it does get a little complicated because with Class C addresses, you only get 256 per Class C, but you can supernet them together using a different subnet mask, and with Class Bs you can supernet these. With the Class A, you can actually subnet this so that you're not using the entire Class A network, but you're using a smaller subset of that. That's not really important for us right now. Just know that these are your options as far as the private networks. Now, you may see or you may hear people talk about, well, I'm using the 240 dot or 240 to 255 dot x dot x dot anything dot anything. And you got to know that don't use this. Because this range, while it's not publicly routable, is reserved for future use. What that means, we don't really know. But some places actually use these addresses when they're not really supposed to. Now, if you assign these to your internal computers, would it work? Yes, it would work. But then if they decide, hey, you know what, they're no longer reserved. Now we're going to use them for who knows what. This is going to be the new cell phone range of IP addresses. It's going to mess everything up. So don't use the 240 or 241 or 242, anything like that, because those are reserved. You're not supposed to use those. And quite honestly, you have a huge chunk of private networks to choose from inside. So you have all these choices. What is it you're going to do? Well, this is where you can take my recommendations, or you can sell them on eBay, whatever you want to do with my recommendations. I recommend, if you're setting up a network inside a router, so you're setting up like a corporate network or a small business network, don't use this. This is overused. This is used everywhere. Everybody uses this range. Every router that you buy from Walmart is going to have the 192.168.something.something address on it. You're going to run into collisions. If you can avoid it at any cost, don't use this. Usually for home, using a 192.168 range is going to be okay, because in your house, unless you have more than 254 devices, it's probably going to be fine just to use a Class C network at home. But for a small business or a corporate environment, my goodness, if you can avoid using any of these 192.168 addresses, you're just going to save yourself a boatload of hurt. Now, a Class B network, this is interesting. Class B private networks are not very common, at least in all the businesses I've been. They're not very commonly used, and I think one of the only reasons they're not terribly commonly used is it's kind of hard to remember exactly what range it is. 172 is easy to remember, but then anywhere from 16 to 31, I think people just kind of don't use this because it's not as easy to remember as the Class A, 10 dot anything. Now, this is one that's used. Most big businesses, most small businesses, most educational places will use a 10 dot something scheme just because there's so many addresses available. The one downside of this is if you use the entire Class A so that you allow yourself 16 million addresses, when you do things inside your company, like if you're trying to set up a network monitoring tool that possibly scans your network range for devices, it's going to take a long time if it has to scan 16 million addresses. So if you really want to use a Class A, maybe subnet that or chop that up so that you're doing 10.1.something.something and use a subnet mask of 255.255.0.0. And that way you would only be using 2 octets, which is still, we're still talking 16,000 addresses. So that's still a ton. But I recommend, if you want to be, the nerdy elite, possibly set up one of these 172.16 or 172.17 in this range, because it's not very commonly used. And not very common is a good thing, because that way if somebody brings in a router off the shelf that they bought at the local department store, it's not going to clash with your internal network. So I really am a big proponent of using this range of private addresses, not because there's anything wrong with using the other private ranges, but just because it's not used very often. Now watch, everybody's going to watch this video, everybody's going to use the 172 range, and they're all going to say, everybody uses that. And maybe that's just wishful thinking on my part that everybody's going to use it. But I like the Class B range. Oddly enough, I personally use, in my businesses that I manage, I use the 10 dot range. And I use it because it's easy to remember and there's a lot of addresses available. But quite honestly, the next part I'm going to talk about is that you should document whatever you do. So don't use a 10 dot range just because it's easy to remember. Document things so that you can find them. And this 172 range is kind of a neat range to use. So anyway, that's my way too complicated discussion on what private network addressing to use on your network, but hopefully you have a feel for at least what's available. And quite honestly, if you just want to pick your favorite, by all means go right ahead. Just know that you might run into troubles if you use this 192.168 range. And next we're going to talk about how we actually assign those addresses. Now I know at this point you're probably realizing, you know what, Sean, we haven't even looked at a computer yet. And I know that's the case. We just have to do a little bit of planning so when we get to the command line we know what we're doing and we can just do it. So anyway, when we talk about static addressing, this is when you assign the address to the computer manually. So you manually set the address and it doesn't change. If you set it to 10.13.13.5, then it's always going to be 10.10.13.5 because you've assigned it manually. You've manually set that address. So that's what it's going to be. That's what a static address is. Now, a dynamic address is usually set with a DHCP server, and dynamic means just that. We talked about this a little bit when we talked about IP addresses from your ISP and that kind of thing earlier. But one of the interesting things you can do is have a static DHCP assigned address. And this is kind of a cool feature. This is kind of like the best of both worlds here, because you know what your particular host's addresses are going to be, but you don't have to go in and manually assign them. These are assigned by a server, but they're based on rules you set. So basically you say, okay, the MAC address of 00:FF:35:, a MAC address, which I'm sure you're familiar with, gets the address of 10.13.14.7. And so when the computer goes to get its DHCP address, instead of getting a random IP address in a range, it's going to get this statically assigned IP address assigned by the server. This is really nice for some things like, say you have a lab full of computers and you'd like to be able to remotely control those computers so that if somebody needs assistance you can control the computer that they're on, but you don't want to go and manually assign each IP address because you'd like to be able to change the addressing scheme by just changing like a DHCP config file. Well, if you use static DHCP addresses, you can know what each computer in that lab's address is so that you can do things like remotely control it with VNC or something like that. But at the same time, it's given, or it's assigned every time it boots up. So if you wanted to change the addressing scheme of an entire lab, you can do that just by changing the DHCP configuration. When the computers reboot, they get the new static IP that you've assigned via DHCP. So it's a little bit complicated to wrap your head around, but not too bad. It's kind of the best of both worlds. Now I am going to say, manual addressing, there's nothing wrong with this. I really recommend that you do this to servers. And the reason that I suggest you do this to your servers is because, is it possible to do static DHCP with servers? Well, sure, for all your servers except usually your DHCP server. That gets a little chicken and, which comes first, the chicken or the egg type situation. But you can assign servers this way, and I'll be honest, I tried to organize my entire network, and I thought, you know what, if I just have all of my addressing done with static DHCP, I will have a list of all of my servers and all of my clients. I'll know exactly what everybody's IP address is, and I'll have a list. The problem is when something goes wrong on your network with DHCP, and that something could be your DHCP server dying. Let's say your DHCP server has died. Then all of a sudden your servers, you can't connect to them because they're not getting an IP address. Or something that happens, unfortunately, in my district more often than I like, somebody brings in a rogue DHCP server and it starts handing out addresses that are not correct. So for example, your server goes to renew its DHCP server and then gets an address from a rogue DHCP server. all of a sudden it has an address it's not supposed to have, and you can't connect to it anymore. So I really recommend that your servers all get static IP addresses on your network. Again, that's not the only way to do it, but I've been burned a couple times, and I really recommend that you set static IPs for your servers. It's a great way to go. For guest accounts and for a lot of situations, dynamic, you just say, you know what, I want to assign the range of 10.10.10.1 to 200. All those 200 addresses I'm going to put in this dynamic pool, and when the computer boots up it can get one of those. And that's just a dynamic addressing, and that's, will support up to 200 clients. So a lot of times if you'll have a range like this, so that if people bring in guest computers, they'll just get a randomly assigned IP address. But static IP is great for hosts that you want to have a certain IP address, but you don't want to go and manually set them one by one. So anyway, hopefully that clears things up about static, dynamic, and static DHCP, and some of the situations you might want to use one over the other. So here we are. Finally, we're at computer screen. Now you'll notice with the little circle thing here, this is an Ubuntu install. This is actually, I've installed a GUI on top of this Ubuntu server, and the reason I've done that is because I'm going to be showing you some things in the GUI and the command line, and so we'll go back and forth. As far as servers go, you can have a GUI installed. The server will work just fine. Generally on servers, there's just the command line interface because the X server uses memory and CPU power. We don't normally need this, but for our case, we're going to keep the GUI here just so we can show you both ways to administer some different things. The first thing I want to show you, of course, we're still talking about networking. Now on an Ubuntu system, the networking in the GUI setup is going to be controlled by the Network Manager applet. Now you can see, if I just right clicked here, you can enable networking, enable wireless, like networking is enabled, so we can get online. We can edit connections, and you'll see you can manage wired connections, wireless connections. If you're going to constantly use the desktop, like if this is a desktop machine and not a server, I recommend using the Network Manager both here in Ubuntu and in CentOS, which we're going to look at in a little bit, because it's a really nice way to see that you're connected. It's easy to edit multiple configurations, and honestly, without Network Manager, wireless is a pain in the butt to manage. But Network Manager does a great job of configuring wireless interfaces and finding access points and storing WAP keys and all that sort of stuff, or WPA keys. It's really a great thing if you're a desktop user. If you're going to use it as a server, though, one of the things I recommend, and this isn't necessary, but I recommend getting rid of Network Manager. And here's the deal: if you are in Ubuntu, like I am right here, let's become root. So just to save a lot of sudo commands, go into etc. network, and here are our files. Now, if you watched any of the LPIC training series with me, you edited these before, so this should be familiar. If not, that's okay. We're going to look at it. We're going to look at interfaces. Now, interfaces is this file. If we edit this file manually, Ubuntu tries really hard to ignore Network Manager settings if you've managed this file on your own. So if you make changes to this file, supposedly Network Manager is supposed to no longer configure your interfaces. I've found that sometimes that's the case, or sometimes Network Manager battles with your manually set interfaces file. It's just I just don't like the chance that Network Manager is going to take over. So I quit and just simply go apt-get remove Network Manager, and it's going to say remove Network Manager and the GNOME, Network Manager GNOME. So yes. So Network Manager has been removed. You'll see up here, Network Manager is not running. It's kind of freaking out. It doesn't know what to do. Network Manager is what this is letting us know about. This is like the Network Manager applet telling us what Network Manager is doing, and it says networking is disabled. Well, Network Manager is disabled. If we want networking to work, we need to manually edit this interfaces file. which is what we wanted to do anyway. So let's say this is a server. We're going to go through, and this is how you configure your interfaces. LO is the local host. You just kind of leave this alone. This is the loopback interface. You want it to come up automatically. Same thing with Ethernet 0. We want it to come up automatically, but since we've disabled Network Manager, actually we've uninstalled it, we need to add some things so that the system knows what to do with ETH0. So to create a static entry for this network address, we hit enter, and you'll see when Network Manager was installed, it actually commented out this part of the stanza right here. Well, we're going to add something similar. We're going to say interface, so iFace ETH0 iNet. Instead of DHCP, we're going to say static. And then enter, and then we have to tell it what sort of static information. If it was just DHCP, boom, we'd be dead, or we'd be done. Wow, we'd be done, and then it would automatically assign an address. But we actually need to tell it what address. So address, I'm going to say 30. This is my home network here, so I know that I'm using the range 192.168.1.1 through 255, and I just have to make sure that I'm not using an address that's already assigned to something. Netmask, so it's I'm using it as a Class C address, and the gateway address is my router, and then that, then that should do it. So what we've done before I save this, auto ETH0 means automatically come up. When the computer starts, I want you to start Ethernet 0. And then we have to tell it what Ethernet 0 is. Well, it's interface. Ethernet 0 is an iNet interface, and we want it to be statically assigned an address. And the address is 192.168.1.30. Netmask is 255.255.255.0. And the gateway address for us to get out to the greater internet is 192.168.1.1. So we save this file. Now, one more thing we do need to edit. We need to check out. So here, the name server was assigned by Network Manager before. It didn't delete that entry, and this actually is the DNS server in my office here. So we're going to leave that just as it is. All right. So now let's do a quick reboot, and we'll see if networking is all set. Okay, so Ubuntu is restarting. Our desktop is loaded. You'll notice the Network Manager applet is completely gone. Remember, we uninstalled it. After our reboot, there's nothing up there at all, which means that we're going to have to look. Let's run ifconfig and see. All right, it looks like our address was statically assigned, so that's awesome. I didn't specify a broadcast address. You can, inside that etc. network interfaces file, you can also specify the broadcast address. I did specify the net mask, and let's just see if we can ping Google. That means that routing is working, so our gateway is working, and also DNS is working. And it looks like we're in good shape. We're getting a reply from Google, which means our packets are making it all the way through the network to the greater internet. Now, let's look at the... So you'll see this is the file. This is the file that we edited, and that is the address that was assigned there. If we wanted to add a broadcast address, you could do that. It normally functions without it, but you can add a broadcast, and then what would the broadcast be in this scenario? Well, it's easy to calculate. The broadcast address is actually going to be 192.168.1.255. So anyway, you can add that if you want. Usually it's not necessary. But this is how to statically assign in Ubuntu. I'm going to mention it again, but I want to mention it really quickly. When you start assigning addresses, please write them down. A spreadsheet's a perfect place to do that. Once all of your addressing is done, you have that spreadsheet. I recommend printing it, putting it in a filing cabinet, keeping that updated, printing it if you make changes. Having documentation for what is addressed to what is key. And I can tell you that firsthand because I have a tendency to not document well, because I know you all think that I am the perfect sysadmin, and if you don't, don't burst my bubble. but I tend to sometimes just make some quick decisions, assign an IP address, and then this past week actually at work, we had a new security DVR put in, security cameras with the DVR. I assigned an IP address that made sense, and it turns out it was one that I had already assigned to a computer. And so unfortunately I had some conflicts on the network, and it took me about an hour to figure out what it was I assigned that address to. So document, 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 document. It's really, really important. So this is how, anyway, I'll get off my soapbox and we'll move on. But this is how you assign a static IP address in Ubuntu, the same way whether you have a GUI or not. So if this is just a command line server, this is how you would assign the address manually. It's pretty similar in CentOS, so we're going to look at that next. We're going to go over it quickly because it's pretty similar with just some slight differences in where the files are and how they're laid out. So let's look at CentOS. Alright, here we are in CentOS, and it's a similar process. Again, I recommend if this is a server you're going to statically assign the IP address that you remove Network Manager. Not required, you can still edit and make a static IP entry with this Network Manager tool. It will allow you to do that. IP4 settings, you can set it to manually and then assign a static address here. I've had really bad luck with Network Manager over the years, so I just like to get rid of it. So here, let's become root. So we'll use yum and we'll remove Network Manager. I think that's how it's specified here in CentOS. Ooh, not remote. Yum remove. And that gotta spell things right. Let's see. Yep, it's called Network Manager. Is this okay? Yes, we're gonna remove that. Now, if you remember when we were in Ubuntu, it was actually Network-Manager, all lowercase. Here in CentOS, it's Network Manager, one word with a capital N and a capital M. Unfortunately, that's the kind of thing that you get when you go from distro to distro. If you're having an issue, a lot of times what I'll do, I just happen to remember this time, but what you can do is use our friendly tool, grep. So let's say yum search. We're going to search for, we know the word network is going to be in there. So this is going to find everything that has a network, the word network in it, and then we'll pipe that through grep manager. And this should give us a list of any packages that yum knows about that contain the word network, and then we're going to grep for manager. So there it is, Network Manager, awesome. A network connection manager and user applications. So that would be the way that if you don't know what it's called, something like this where you can use yum, search for network, and then pipe it through grep and search for the word manager. You could do the same thing in Ubuntu, but in Ubuntu it would be apt cache search network, pipe it through grep manager, and you would get the same thing. You'd get the name of the package. All right, this .i686, that's just the architecture that it's on, but this is the name of the package, as you can tell, because we just removed it up there. All right, so bam, Network Manager is gone. And now if you remember in Ubuntu, we needed to edit one file so that we had the information for static IP addressing. In CentOS, it's a little more complicated. We're going to go into the sysconfig folder. This is where CentOS stores a lot of configuration information. So if you look in here, there's a lot of different files. A lot of the information that it stores about setup of utilities is in this etc. sysconfig folder. Specifically where we're going to go is in the network scripts folder. See, there's a whole bunch of stuff in here, but specifically this ifcfg-eth0, there's going to be one of these for every interface. You see here's one for L0. In Ubuntu, they stored it all in the one file, which I personally find much more convenient, but this is how CentOS does it, so you need to learn how to do it. And we're going to edit ifcfg-eth0, and even the format is way, way different. Now, generally, you have something to go from. Same thing here. We have something to go from. So here, boot, well, devices, eth0. Boot protocol, we're actually not going to use a boot protocol. So let's just say none. That's the flag that you can use for that. Hardware address, now you can specify the MAC address. I personally like to get rid of this. Now, if you have multiple cards, this is key because it can specify which is which. Like if it loads up and they don't load in the order that you expect, like ETH0 becomes ETH1. If you put the MAC address or if the MAC address is specified, then that's the card that it's going to assign. But I don't like that because a lot of times with virtual machines, the MAC address will change, or it just gets messy if you specify the MAC address. And it's not required to set an address. All right. So, Network Manager controlled? Well, no, absolutely not, because we don't have Network Manager installed. So we can change this to no. We could actually just erase that line, but we can leave it there. It's not going to hurt anything. On boot, this means will it be activated? Yes, we want it to be activated. This is like in Ubuntu when it said auto ETH0. This is the equivalent in CentOS. On boot equals yes. Type Ethernet, and now we need to add some stuff to assign it an address. All right. So let's say we need to know what network it is. We don't have to put this in quotes. You can if you want. I'm not going to. The network address is 192.160.1.0. Again, this is not the IP address. This is the address of the network. The net mask equals 255.255.255.0. Now the IP address. Again, unfortunately, you kind of just need to know the flags that CentOS is going to expect. So IPADDR, and then the address we want to assign. So 192.168.1. Last time we did 30. Let's do 31 this time. All right. So we'll hit escape. We'll save this file. So basically, we've assigned an IP address. This is the network address. This is the netmask address. This should all be activated on boot. This is the device name. It's not trying to use DHCP, and Network Manager is not controlling it. So that's what's going on here. Let's save this file. And you'd think we'd be done, but in Ubuntu, you remember we added the line specifying the gateway, right? The gateway address or the router address on the network. Well, that's not where you put it here in CentOS. In CentOS, there's another file in the sysconfig folder, and it's a file called network. All right, so let's look at the network file. And in here, networking, yes, we want networking. The host name, this is the host name of my computer. It's already set. But since DHCP is no longer assigning a gateway, we need to add that information here. So gateway equals 192.168.1.1. So we need to add that to this network file. We save it. Now let's look at the etc.resolve.conf file for DNS information, and we'll see again Network Manager originally put this in. This is the correct name server. So we're going to leave that information in there. It's important to look because if Network Manager was never set up and it never assigned it, or if DHCP assigned a different gate or a different name server than you want, you need to come in here and change this. But for our purposes, that's exactly correct. So we'll just make sure that that's there. And now we should be able to reboot this computer and have it be online just like our Ubuntu computer was. Let's give it a run. Okay, so the system started back up. Now, just to clarify, I didn't have to reboot to activate that. I could have just restarted the networking scripts, but I like to reboot just to make sure that it's going to come back up when the computer actually does restart. So let's take a look. If config, well, it looked like it assigned the proper IP address. That's awesome. It calculated the broadcast address. That's pretty neat. And let's see. Let's give it the ultimate test. Ping google.com. Oh, yay, look at that. Sure enough, it was able to look it up with the DNS, and it's able to route out to the internet and actually get a response. So that's how That's how we go ahead and assign static IP addresses. Again, you can do it with the GUI tools, and that's okay. I've just had bad luck with using Network Manager or GUI tools to assign static IP addresses. I like to just remove all that stuff and do it manually. If you don't have a GUI installed, manually is your only choice. So that's the way to go about it. Anyway, that is how to do static IP addresses. Next, we're going to go into our advanced stuff and talk about Ethernet bonding. It's really cool stuff, and it's a great way to utilize those multiple Ethernet ports that come on most servers nowadays. So Ethernet bonding, or link aggregation as it's sometimes called, basically means you just have the two or more Ethernet ports on your server working together, and there's a bunch of ways they can work together. In fact, with the Linux kernel, the bonding ability has seven different modes that it works in. The modes are numbered 0 to 6, so it's 7 of them altogether. And we're going to go, I'll just briefly tell you what the difference between them is. Mode 0 is balance round robin. It means that packets are transmitted one after another. So it goes back and forth, back and forth, back and forth between the two or more. So it could be, 3 or 5, or however many bonded interfaces you have. But it goes round robin, sending the packets out. Mode 1 is active backup. This means that the additional Ethernet ports remain inactive, so they're not used until the primary one fails, and then this one takes over. It's an active backup. Mode 2 is balanced XOR. Instead of going back and forth packet to packet like round robin does, XOR uses a hash of the destination's MAC address and then sends to those MAC addresses based on that hash. So basically, if it's in mode 2, Ethernet port 0 will always send to a specific MAC address that it figures out, and Ethernet 1 or Ethernet 2 or Ethernet 3 or Ethernet 4 will go to each individual ones. So what this does, this provides, in fact, let's start at the beginning. This balanced round robin scenario offers both load balancing and fault tolerance. So there's my little key over here, because if one fails, then it just uses the remaining ports. Active backup just provides fault tolerance because the other port or ports just stay inactive. This balanced XOR provides load balancing and fault tolerance because just like the top one, it will pick up and use the remaining ports if one fails. Now the third is just broadcast, and basically what broadcast means is just that. It's not really an aggregation, it just simply broadcasts all the traffic on both interfaces, which it's useful in things like, if you have a partition broadcast domain and you want to have highly available servers. Not terribly common in the things that I use, but it's a possibility that you can use this for broadcasting on all the ports. Unlike active backup, where a port will remain inactive until needed, with broadcast all the ports are doing the same thing. This provides fault tolerance, but not load balancing because it's all the same information that's being broadcast. 4 is the link aggregation protocol is specified by IEEE. This is 802.3 AD, which is the standard, and this does both load balancing and fault tolerance using the, like I said, IEEE specified protocol for load balancing. Then the last two, balanced TLB, this provides load balancing and fault tolerance, and so does this one. Load balancing and fault tolerance. The difference being that balanced TLB or transmit, this will balance outgoing information across multiple interfaces, but all incoming traffic goes to a single Ethernet port. So it's important to realize that all this balances is the outgoing or the transmitting traffic. With the balanced ALB, it actually does some magic with changing MAC addresses very quickly, and does, well, actually they both use the MAC address trick, but this one does it for both outgoing and incoming. So they both provide load balanced and fault tolerance. Now you'll see I starred 3 of them, and the 3 that I starred require that your switch supports those modes. So whether you're doing the balanced round robin, balanced XOR, or the 802.3 AD, your switch has to support it, and it'll most likely have to be configured to support that. Port trunking, I think Ether channel is what Cisco calls it. I could be wrong on that, but 802 or 802.3 AD, this is the standard that your switch may support. Sometimes it's to have your switch support this. It's LACP mode. Basically, you're going to have to look it up for each individual switch, but if you have a managed switch, chances are it's going to support this type of an interface. The other ones do not need anything special on the switch, and that's because, like active backup, this isn't doing anything at the switch level. It just activates one when it falls offline. Broadcast, you're just broadcasting on all the ports. Generally, it's not even on the same switch. It's generally broadcasting on several collision domains. And then these two, they don't require anything special on the switch, except you have to be really careful. And this is the key with all of these. You want to test. Because to do things like this load balancing with mode 5 and 6, you have to have access to change the MAC address on the cards, so your driver has to be able to support that. So this is going to vary from manufacturer to manufacturer and driver to driver. So this is dependent on the actual network cards you use. Same thing with active backup. You're going to have support for doing some low-level stuff on the cards. So whatever you decide to try, the best thing to do is to try testing it. If your switch will support one of these modes, I would really recommend using one of the modes that is designed, like specifically I like this one a lot because it's a standard. 802.3 AD is a standard for link aggregation, and if your switch supports it, bam, you're good to go, because you don't need any special support on the card to be able to do that. It's all handled with a protocol and with the switch. So anyway, those are the different bonding modes that we have. My recommendation, if I were to say to pick one, if your switch supports it, pick this. If not, you can try modes 5 and 6 if you want to get some load balancing going on. Otherwise, you might be stuck with just the ability to do an active backup. For example, in my home network, I don't have support for anything except this active backup on my server, which is kind of a bummer. You don't get that load balancing, but it's nice if one fails, the other one will just pick up and carry on. Alright, so let's look at how you actually configure servers to do that. It's actually much more consistent in CentOS. You do it the same way that you've done it for many versions. So we'll do that first, and then Ubuntu, it seems like every version something changes, and that's really frustrating. But I'll show you the kind of thing that you're supposed to do, and hopefully from here on out, with like 12.04, the current version, it'll be more and more consistent in how you set up link aggregation on Ubuntu. But let's take a look at CentOS right now. So here we are in CentOS. Now, since we've last looked, I've done a couple things. I restored this to my snapshot. You gotta love virtual machines. And so I have Network Manager is installed again. But what I've done is I've added a second Ethernet interface. So we have Ethernet 0 and Ethernet 1. Now, I'm going to get us back to the point we were before, in that I'm going to remove Network Manager. I do not think Network Manager itself supports NIC bonding, so this, I believe, is the only way you actually can set up link aggregation, is by removing Network Manager from the scene altogether. It's possible that it would recognize the Bond 0 interface that we're going to set up, but again, I've just had bad luck with Network Manager. You can try it. Perhaps it'll work great for you, and I'm just an old curmudgeon stuck in my ways. But it's good to understand what's happening under the scenes anyway. So we'll go into the sysconfig network folder. Network scripts here in CentOS. And here we have all of our links. Now what we're going to do is create a new file, because the bonded interface is actually used just like another network interface in the system. So we're going to create a file called ifcfgbond0. Okay, you'll notice it's just like the ifconfig-eth0, but it's called bond0, and that's what that's what we're going to set up in a little bit, so that the Linux kernel sees that as an additional interface. But anyway, we'll set this up. Now we need to set this up as the network interface. So device name, bond0, IP address, remember IPADDR, 192.168.1. Let's do 30 again. Actually, yeah, let's do 30. That's fine. I know that's in the range. Network, just like we did before. Just those things. It's really frustrating if you don't get the exact syntax correct. But no, not user controlled. Boot proto equals None. Now, why is the boot protocol none? Well, because we're assigning this address statically. And then on boot, do we want it to come up when the system boots up? Yes. Okay. So this is configured just like an Ethernet, just like the Ethernet interface that we configured just a little bit ago, but it's called bond 0. Now this device doesn't actually exist yet. We're going to create that in just a minute, but just so you realize that this is just another network interface configuration. We've done nothing different than when we configured ETH0. Okay, so here we have ifconfig bond 0 is right there. Now we do need to edit this one because this is no longer going to be a standard network interface. So let's edit that. So now device is ETH0 still, yes. Boot protocol, it's not going to be DHCP. Remember, I restored this from the snapshot. That's why it looks different. Boot protocol none. Actually, get rid of this hardware address line. User control, no. Network manager controlled, no. Network manager doesn't even exist anymore. So we can erase that. You could leave it in there and change it to no if you wanted. I just like to keep things clear or clean. On boot protocol, so we need to add a couple things here. Let me just, for the sake of clarity. So these are things that we're familiar with. Type Ethernet, we don't even need that. Just the things we need. Now these are the things that are going to be different. So master equals bond 0. So this should make sense just logically. The master that this bonded port is going to be serving is called bond 0. Slave, yes, we need to be a slave. Okay, so it's saying this is a slave to the bond 0 interface. All the rest is pretty similar. Device ETH0, boot protocol none. It's not going to get its address via any method, to be honest. User control no. On boot yes, we want it to come up on boot. You can have these in quotes or not. That doesn't really matter at all. We'll save this. So now we have that there. Now you'll remember that I actually added the second Ethernet card, so we have an Ethernet 1 card. Now it's not set up here because Network Manager never configured ETH1, but we know that it exists in the system. So let's just copy to save time. Like that. So what I've done is I've created a copy of ifconfig-eth0 to ifconfig-eth1. I could have retyped the entire thing, but we want it to look similar, except for this one little character. So everything else is the same. Device ETH1, boot protocol none, user control no, on boot yes, the master is bond 0, and the slave, yes, it's going to be a slave to that bond 0. Alright, so now all of our interface config files are configured. We have Ethernet 0 and Ethernet 1 set up as slaves to the master, which is bond 0. And this one is set up as an Ethernet device right here. Okay, so this is all set up as an Ethernet device, but it's bond 0. Now, again, there is no bond 0 device yet. What we need to do is add the kernel module so that it will load and we will see that device bond 0. So let's go into etc modprobe.d directory and see what's in here. Now all of the files in here are going to be loaded when the system boots up and load the modules and the options that are listed in here. So we're going to create a new file called, we can call it anything you want. We'll call it bonding.conf so that it makes sense to us. And inside here we're going to say alias bond 0 bonding. And what this means is it's aliasing the device bond 0 to the bonding kernel module. And options for this, for bond 0, we want to have, remember we talked about those modes? Well, what mode do we want? I know my system is going to support the active backup mode. So I could type active backup, or I can just type mode 1. Remember they're numbered 0 to 6. So we're just going to say it's an active backup. And then we do need to add this MIIMON. This is how often it monitors the mode. We'll say generally you just put 100 milliseconds in here. This is something you can tweak. I just had a thought. Let's see if we can make this break. Okay, so instead of mode 1, which I know will work, let's try mode 6. Remember, mode 6 is balance-ALB, where all of the incoming and outgoing traffic is load balanced and fault tolerant. I don't think that's a word, but it's fault tolerant based on some magical MAC address swapping that it does in the switch. I have no idea how that's going to work inside my computer system here, but we'll try it. This is what we would do in the real world. Want to see if mode 6 is going to work, because I know that my virtual switch doesn't support 802.3 AD link aggregation mode. So let's try this. Let's see if it'll work. Sometimes it will, sometimes it won't. Again, depending on the card driver and stuff like that. So we'll save that. Now we can just activate this right now by using modprobe on the bonding thing, or on the bonding kernel module. But since we've removed Network Manager and it's kind of in a weird state, I just suggest that we restart it. So let's restart. Alright, the computer is rebooted, and I have to confess, while it was rebooting, I realized that I made a mistake. And perhaps you've already found that mistake, and that's okay. You can sit back in your chair and laugh at me, but we'll try to troubleshoot it together, because I think that's invaluable. Because believe it or not, I think everybody makes mistakes, so this is a good learning opportunity for us. First of all, the computer has been restarted, so let's look at what sort of internet configuration we have going on here. So it shows us all of our interfaces. We have the Bond 0 interface, which appears to be configured correctly. We have an internet address, we have the broadcast address, and netmask. Ethernet 0 is running as a slave, as is Ethernet 1 running as a slave. So that's awesome. Looks like both have traffic that are going on them. That's really, really good news. If both of these have traffic on them, that means that they're working correctly, or at least they're working. So let's see what we can do. Let's try to ping Google. Ping google.com. Network is unreachable. Now, I know what's wrong, but my first instinct would be, okay, well, it doesn't support that mode 6 that we tried. And what we would do is go, well, first let's become root. We would go into this folder, and well, maybe you saw this mistake too. Well, I'm just full of mistakes today. Remember I said you can name it anything you wanted? Well, it's a good thing, because apparently I can't spell bonding correct either. But that's actually fine. Like I said, it doesn't matter what it's called. So vi bondend.conf. And this is where I would try changing the mode like to mode 1, just for that active backup. But if I were to do that and reboot, we would have the exact same problem, because this actually isn't the issue. I'm not sure yet if mode 6 is going to work, but I made a bonehead move that we can correct pretty easily. So let's go into etc. network. Nope, wrong system. Sysconfig, network scripts, all these files. Let's edit. Now this all looks correct, so it's all configured correctly, and we did see that it assigned that address, so it's not in this file. So let's see if we just open up the network file. Networking, yes, hostname, but what is it I forgot to add? The gateway. I forgot to add a gateway, so while it might be working on the network, let's see. Is it working on the network? I can't ping Google. Remember we tried pinging Google. Network unreachable, but I bet we'll be able to ping 192.168.1.1 because it's on the same network and it doesn't require a gateway. Boom, it's responding. Now this tells us something. This tells us that our bonded Ethernet interfaces are working. All right, we're able to ping out of this computer and hit my router. So we know that's working. It was just that I forgot to add the gateway in that etc. sysconfig network file. I forgot to add that gateway. So if we reboot the computer now, it should work. In fact, we can just add the route manually, but let's reboot to make sure that it's really going to work on boot up how we expect. Alright, our computer is booted back up. Let's open a terminal, see if we can ping out of the network. And sure enough, there we can. We can ping out of the network. So it looks like everything is going well. Hooray, hooray, and lots of happiness. Do an if config. We'll look at the interfaces, what's actually happening. So we have bond 0, this interface, it's received about 75K, it's sent about 15K, and it's split it up between these two almost evenly. Received about 37 kilobytes from here, about 38 kilobytes from here, so you put those together to get that 75. So yes, that part's working. Actually, it didn't split these quite as evenly, but that's still not too far off. It's splitting the transmit and splitting the receive, so both are being used. It's load balancing across that bond 0 interface. We're using mode 6, or the balance ALB, so it's balancing both incoming and outgoing. Now, you'd be tempted to think, hey, everything is working great, Sean, once you put in the gateway. I'm so proud of you for figuring that out. Now things are working well. And for the most part, that's true. This appears to be working very, very well. But what you need to do is, before you put this in production and say, hey, things are working great, you need to test all possible scenarios, because I just happen to know that this isn't working quite as well as you think it is. Now it's load balancing, that part's working, and we can get online and we can ping everything just fine. But if we were to jerk one of these cords out, and now it's all virtual, so in VirtualBox, if we were to go and unplug one of these cables, see I have adapter 1 and adapter 2, if we were to unplug one of those cables by unchecking that and clicking OK, so now we've effectively unplugged one of the cables. Now, if this is truly working, we should be just fine. We should be able to ping Google. Aha! But what's wrong? Something's not working. All of a sudden, we can't ping Google. In fact, we can't even look up what Google.com is. We can't even ping our local router. Everything seems to be messed up. If config shows that everything is still working fine, everything seems to be working well, but there's something wrong with the way that VirtualBox handles a bonded interface and its internal virtual switching. It just does not handle that fault tolerance when one of them goes offline. So it appeared that everything is working, but it just does not. It's just not going to reach out on the network. So now we can plug that interface back in, but even that probably won't fix it, because this is an underlying something's going wrong problem. So cable connected, click OK. So now our cable's plugged back in, but even still we can't get out on the internet. Probably, gonna play along in your book with me here. If we become root and we take the interface down, so if down to take the bonded interface down, then if up to bring it back up. See, all of a sudden we're back in business. But this is important that you test all the possible scenarios to know that if you set up a bonded interface in VirtualBox, it's going to appear to be working great. But something's goofy when you try to do fault tolerance. It just kind of freaks out. So this will work most of the time in a real server environment, or if you have a more robust emulation, like server emulation environment, like ESXi or something like that. I have bonded interfaces working really well inside my ESX machines, but in VirtualBox right here on a desktop, it's not going to work really well with bonded interfaces, so you need to test that really thoroughly. I'm going to show you how to set up a bonded interface inside Ubuntu before we close out and go back over stuff. But we've kind of walked through how you would test things, and you've seen it fail, and you've seen me make mistakes, and I'm not going to edit it out, I promise. You're going to see all the mistakes that I made. But let's look over at Ubuntu, and then we'll sum up and we'll get on to the next nugget. Before we move on to configuring Ubuntu, I just wanted to show you on the VirtualBox website. This is another step that you should probably take if you're trying to troubleshoot your network. It turns out that this is a known issue using bonding with VirtualBox in a Linux host. It doesn't when you disconnect the cable, all of a sudden it's lost, and it's something to do with the virtual switching that goes on. So it's not just us. And then hey, it's time to stop trying to make it work, because it's a problem with your underlying system. Now it's possible that we could go through and troubleshoot and really get it going, but that's really not the focus of this nugget. We know that there's some issue going on, and we actually configured it correctly, and it was working load balancing. It's just that disconnected wire off just for some reason makes VirtualBox freak out. So anyway, I just wanted to show you really quick that also following up by searching to see if you're having or if anybody else is having a similar problem is a really good troubleshooting skill to have, because if you see that it's replicated somewhere else, it will give you, if nothing else, peace of mind that it's nothing that you've done incorrectly. Also, if you really had to get it working, if you follow this thread, you might be able to figure out some workaround that somebody did. So anyway, just a little side note. Let's move on to Ubuntu and show you how to bond some NICs. Now, I am a big fan of Ubuntu, I really am, but the bonding is a little bit annoying in that it seems like every version it either regresses and doesn't work the way it did before, or they completely change the way that bonding is set up. It's a little bit frustrating. So I'm going to show you right now. Let's become root, just to save some errors when we forget to type sudo. One thing, first of all, it does not come, like CentOS came with the program if-enslave. That's the one that allows you to bond. That's installed by default. It's not with Ubuntu. So the first thing you do is install this program called if-enslave, or interface enslave. So we'll add that, and this gives us the ability to add bonding to the running kernel. All right, so we have to install that. With current versions of Ubuntu, we don't actually have to add anything to the etc modprobe.d folder. That's how you used to do it. You used to do it just like with CentOS. So you would put something in, you would put a file in here with that alias bond0 bonding. Remember that thing that we did with CentOS? But now you don't have to do that, supposedly. Now you're supposed to do everything from within the etc network interfaces file. So we're going to just edit that right now. First of all, before we do that, see I have two wired internet connections here as well. Network Manager is installed, so let's get rid of that. So we'll get rid of Network Manager, just like we did before. Then we're going to edit etc network interfaces. Alright, so here you see we just have the default that Network Manager created. We are going to set up some new interfaces. Let's just make some room. Okay, first of all, we need to set up the bond 0 interface. Okay, so auto bond 0 means auto bring it up when the system boots up. The interface is bond 0. It's an iNet interface. It's going to be static. So we configure this just like we would configure a regular old Ethernet interface. 31, because the other one is actually still running at .30. So .31. Remember, in Ubuntu, the gateway is specified in this same file, which I find much more convenient. Netmask. And then now we need to start adding the stuff regarding bond specifics. So here's where like bond mode is specified. Bond mode, and let's do bond mode 6. Remember, that's the balance-ALB, or the adaptive load balancing. So we'll do bond mode 6. We could either type 6 or balance ALB. That's the name of it. We'll leave it there. We left it with the number in CentOS. We'll just put the name here just to show you that it can be done that way. And we did this in the modules file in CentOS. Here we just add it right here every 100 milliseconds to monitor the link. And then we want to add a line. Now this seems counterintuitive. Bond slaves none. This doesn't make a whole lot of sense. Basically, the problem is if we try to specify slaves here, it's going to try to use the Ethernet 0. It'll hang for a long time. It'll probably eventually come up working, but here we tell the bond interface, all right, buddy, you don't actually take any slaves. Maybe think of this as a politically correct way of doing it. We're going to have the Ethernet ports volunteer as slaves. So say bond slaves none for the bond 0 connection. All right, so that's pretty much it. We've done our entire stanza for the bond 0 interface. Next is the Ethernet 0 interface. We'll get rid of this line. So auto eth 0, the interface is eth0, and it's an iNet interface. And manual instead of static, because remember, it's not getting an IP address. It's not. So it's a manual setting. So this is different than before. So interface Ethernet 0 iNet manual. That's key to recognize that that's a little bit different than what we've been doing. And then we only have the one line here. Bond master is bond 0. So even though we told the bond 0, don't take any slaves, we're telling Ethernet 0, okay, you bind to the master bond 0. Then we do the same thing again for Ethernet 1. Alright, bond 0. Escape. We'll save this file. And it should, now that we have the right program installed, we have the right configuration done. Ubuntu is not supposed to require you to have that information in the etc modprobe.d folder. Remember, it just had it specified right in this single file. Let's reboot and see how it works. Alright, Ubuntu is rebooted here. Obviously I paused it during the reboot process so you don't have to watch that. Watching me is often painful enough. But so, okay, we've restarted. Now all those things should have taken effect. Let's look at what we have in the if config. We have bond 0 is active. It's assigned the correct address. The network mask is correct. Ethernet 1 appears to be up. Ethernet 0 appears to be up. And they've both transmitted data. This is a good sign. Let's try the ultimate pinging out of the network. Drum roll, please. And look at that. So bonding is now set up in Ubuntu as well. Like I said, it's confusing version to version. Back in like 8.04, you had to actually put commands in the etc network interfaces file, and then with 10.04, you had to put it in a modprobe.d folder, just like we did with CentOS. Now most of it, or pretty much all of it, yeah, in fact all of it, is specified in the network interfaces file. Everything is specified here. There's no modules that you have to manually load. So this is how to do it in Ubuntu. This is, I would argue, this is actually easier to configure than CentOS. The frustrating part is that it changes version to version. So I don't want to say that this is how it's always going to be. You may have to actually, if you try this and it doesn't work, Google for your specific version of Ubuntu and see how, or see what's changed. But this is supposed to be how it works from here on out. So hopefully it won't change after this. Maybe they watch this video and say, maybe we should stop changing that. But anyway, that's how it's all set up. I'm not going to try with the fault tolerance. I'm not going to try to unplug the virtual cable, because like we saw before, there's something fishy with VirtualBox. It's going to fail. But these modes, mode 1, which is the active backup, and mode 6, which is this adaptive load balancing, they don't require any special switch. So they're going to probably work even if you don't have link aggregation protocol or 802.3 AD. Even if your switch doesn't support that, these modes should work on their own. But always test it. Always test it, just like we did, because you might find something that doesn't work, like our VirtualBox mistake. Let's make sure we have everything covered. I think this may be the longest nugget in history, and we'll get out the door with this nugget. Alright, back at our bonding slide here, we went over briefly what these do. Now the one that we focused on was this, because it's kind of cool. It does load balancing, doesn't require a special switch, but again, remember VirtualBox had real problems with failover stuff, with fault tolerance. But that wasn't the problem. That wasn't the fault of Ubuntu or CentOS or Linux in general. That was a VirtualBox issue. But these are the different options you have. The starred ones do require that your switch supports that special protocol. This works really well if your switch supports it. I use this in production at work all the time. One of my servers has 7 Ethernet cards in it, all gigabit Ethernet cards, and I bond them all together with 802.3 just because it's a file server, and so I get a lot of aggregate bandwidth that way. But this works really well, like we saw in our setups, and doesn't require a special switch. So this is bonding. Let's go make sure we got everything in this nugget covered. We talked about IP addressing, public versus private. We talked about the private ranges. Just pick a range that works best for you. It could be small, it could be big. You might want it to be something people are familiar with. You might want it to be a little obscure, like that 172 range that we talked about. Static, DHCP, or both. Both meaning that the DHCP server assigns a static address. We're actually going to talk about DHCP server when we talk about services in later nuggets, but just know that that's a way you can assign addresses. We learned how to configure the network cards on different systems on Ubuntu and CentOS with those different files by removing the Network Manager. You can use Network Manager if it serves your needs, but I like to remove that so that I can manually configure those configuration files. And then we spent a lot of time on bonding because I just thought we needed time to bond. No, it's really neat stuff. Bonding Ethernet interfaces is a great way to utilize hardware. Almost every server now comes with that. So I hope that this has been informative for you, and I would like to thank you for watching.